Hello guys, so in this video I will show you my analysis on US cardiovascular data which I have analyzed using Python and Jupyter Notebook. So let's get started. So first of all I have downloaded the data set from the Kaggle and then I have imported some important modules for data analysis like Pandas, which is a great analysis tool, and Numpy. And for visualization I have imported seaborn and matplotlib, and I have set some parameters. Now let's load the data set. So I have loaded the data set and I got these features with their variables and value types. So let's look at the features and then we'll move on. So first of all we have age, which has variable age and it is in days. Age is in days. Similarly we have height in centimeter, weight in kilogram, gender only 1 and 2 is given, so we have to figure out gender, which is a categorical code. So we have to figure out from the data set that who are male and who are female. We have systolic blood pressure, which has variable AP high, which is int, diastolic blood pressure AP low, which is also in int, and we have cholesterol. Under the cholesterol we have three subcategories, which are 1 is normal, 2 is above normal, and 3 is well above normal. And then we have glucose. So similarly we have three subcategories in which 1 is normal, 2 is above normal, and 3 is well above normal. Then we have other features like smoking and alcohol, which are binary in nature. That means, and physical activity also. That means either you are smoking or not, either you are taking the alcohol or not, and either you are doing the physical exercise or not. So 0 is for not doing the activities and 1 is for doing those activities. And then we have our target variable, which is presence or absence of cardiovascular disease. So it is in binary. So if the person doesn't have cardiovascular disease, that is 0, and if it is having cardiovascular disease, then it is 1. So we have to figure out how many males and females are there in the data set by analyzing the data. So let's get started. So first of all we will load the data from my PC. So I have loaded the data. Let's view few heads of the data. So like we have gender 2 and 1, and we have the height, we have weight, we have systolic blood pressure and diastolic blood pressure. Then we have cholesterol categories. So we had 3 categories of cholesterol, 1, 2 and 3. And we have glucose. So glucose also we have 3 categories. Then smoking, alcohol and physical activity. And then we have the target variable, which is cardiovascular disease or not. So over here like 3 patients are having the cardiovascular disease and 2 samples are not suffering from the cardiovascular disease. Now let's get the size of the data. So we have around 70,000 samples and we have 13 features. Like we have 12 features and 1 target variable. So now we are analyzing the categories of each feature. So now let's analyze that how these features are distributed in our data set. So as we can see that only few people don't do physical activity and rest of them do physical activities. Similarly, many of them do not consume alcohol, and for the data set we have almost 50% of patients which are suffering from cardiovascular disease and who are not suffering from cardiovascular diseases. Then we have cholesterol variable. So we have most of the samples are in category 1 and least are in the category 3, which is the danger category. And similarly we have gender, which is either male or female. We don't know which is male and which is female, but one gender is definitely the double of the other. Then we have glucose. intake. So mostly we have category 1, but only few of them are having category 2 and 3, and most of them do not smoke, while very few of them smoke in our samples. So now let's analyze more into our data set. So now let's analyze that which features are leading to cardiovascular diseases. So let's get the data. So the people who are not suffering with cardiovascular diseases are on the left graph, and people who are suffering from the cardiovascular diseases are on the right graph. So cardio is equal to 1 on the right and cardio is equal to 0 on the left. So as we can see that cholesterol over here and glucose intake are the two factors which we can see are the causes of having cardiovascular disease. We will analyze more deeply to see each feature, that how much it is impactful on the cardiovascular disease. But viewing this graph, we can say that cholesterol and glucose are the two factors which are causing the cardiovascular diseases. Now let's find out the gender feature, like which is male and which is female. So if we see the gender 1 and if we see gender 2, gender 1 is double of gender 2, that's why it is showing more data in gender 1 than gender 2. So by analyzing this, we can say that not much conclusion can be driven out from this graph. So let's try another thing. First of all, let's get the information of our data frame. So we have 70,000 entries for each of the data frame and the memory usage is 6.9 MB. So pretty much. Let's analyze unique features, that how many unique parameters are there in each of our feature. As we can see in our gender, like gender with one category are around 45,000 and gender with two category are around 24,000. As we saw earlier that one gender was double of the other, and so this is the relevant information which we can gather out of this. What I did is I calculated the unique parameters of all the subjective features. Similarly, for cholesterol, we have high number of people in category 1, which is good, but we also have around 8,000 people in category 3, which is in danger zone. Similarly for glucose. For the smoking, I can see that around maximum of them are not smoking. So around 63,000 people, 64,000 people do not smoke, while only 6,000 people are smoking. So it is very less ratio. And similarly for alcohol, it is lesser than the smoking people. For the physical activity, you can see that only 13,000 people are not physically active, whereas 56,000 people are physically active. So that is good. And we can see that around 50% we have cardio patients in our data. So this was the analysis by analyzing the unique parameters in our features. Now let's try to get the intuition that who is male and who is female, that whether one is female or male. So I thought that in general most of the men smoke. So I thought that whether it would be a good idea to get the intuition that who is male or who is female. So by filtering out the gender with the smoking feature, I figured out that only 1% of gender 1 and 21% of gender 2 are smoking. So I'm not sure, and I'm not concluding over here that 2 is male and 1 is female, but we can draw some insights over here. Let's not jump to the conclusion. Let's analyze more that whether our intuition is correct or not, whether 1 is female and 2 is male or not. So let's get the height. So generally males have more height compared to females. So over here we can see that the average height of gender 2 is around 170 centimeter and the average height of the gender 1 is 161 centimeter. So this can be a strong evidence to figure out that gender 1 is our female and gender 2 is our male in the data set. Let's visualize this. Let's see the facet grid also. So we can see that for the gender 2 we have more height than for gender 1. So this can be the pretty good conclusion or evidence that gender 1 is female and gender 2 is male. So we can draw the conclusion that around we have 45,000 female and 24,000 male in our data set. Let's see whether smoking impacts on the cardiovascular disease or not by looking at our data. So if we can see that the median age for smoking is 52 years, whether for non-smoking it is around 54 years. So I don't think that our data can get the pretty good conclusion whether smoking causes cardiovascular disease or not. So we can't say anything by looking at the smoking feature that whether smoking impacts cardiovascular diseases or not. Let's get the insights of our data more. So we can see that in the age we have mean around 20,000 days. Let's first convert these days into years, because calculating in years and getting the analysis in years is easier than getting the analysis in the days. So let's get the age factor and then let's convert that into the years. So I have converted them into years. So let's view the age years. So now we have our age in years. So now let's analyze that which age group is more susceptible to cardiovascular disease. I feel that it can be the good evidence or the good feature which can tell us about the impact of cardiovascular disease. So as you can see that we have the data for each year and related cardiovascular disease. So we can see that for around till 54 years, most of them do not have cardiovascular disease, but after 56 years, this graph is rising pretty much. So yes, age can be the factor for the increment of cardiovascular diseases. Let's analyze more that if the old men who smoke are more susceptible to cardiovascular diseases. Let's analyze that. So we can see that around 30% of males who are older than 60 years of age are more susceptible to the cardiovascular diseases if they smoke. So although our smoking feature was not much conclusive on the whole data, but it is pretty much conclusive on the data of having age greater than 60 that smoking is injurious to their health by analyzing our data, and they can get the cardiovascular disease. Now let's analyze one more feature. Let's do feature engineering. Let's calculate the BMI from our given data set. BMI is body mass index, where the weight is divided by the height. So let's get the BMI. So we have the BMI for each of our data set. So we'll analyze that whether the BMI impacts on the cardiovascular diseases or not. In the BMI median, the good BMI is around 25, as it is said, and in our data also it is around 26.3. So I think that it is correct. Let's see the average BMI for women, as we have one as women. So average BMI in our data set is around 28, which is pretty much high. And let's analyze the BMI data for men as well. So we have BMI data for men as 26.7. Now let's see that the people who are suffering from cardiovascular diseases, what are their BMIs? So their BMIs are pretty much higher. It is around 28.5, which is higher, which means that BMI could be the factor for cardiovascular diseases. Now let's see that people who are not suffering from cardiovascular diseases, what is their BMI? So their BMI is lesser than the BMI for the people who are suffering from cardiovascular diseases. Now let's see that people who do not intake alcohol and do not suffering from cardiovascular diseases, what is their BMI? Now let's watch that. So we can see that their BMI is better. So it is around 25.8. So this is a good analysis for figuring out that if a person do not takes alcohol and if he is a male, then the BMI is around 25.8, so which is good. So not intaking alcohol is beneficial for not having the cardiovascular disease. So we can figure out similarly for women, we can see that a healthy BMI is 26.8 for the women who do not take alcohol and do not have any cardiovascular disease. Let's filter out some irrelevant data because we had some ambiguous data also in our data set. So I am filtering out it, and we can see that around 90.36 of the data is still with us. So around 10% of our data was trash. So we have filtered out that data. Now we'll conclude our analysis by correlating each feature, and we will find out that which feature impacts how much for the cardiovascular disease. So first of all, I have taken the correlation method as Pearson. So now let's view our cardiovascular data with all our parameters. So here we can see that the age is the factor, the weight is the factor, systolic and diastolic blood pressure, and the cholesterol, as well as glucose. So these are the factors which are responsible for the cardiovascular diseases shown by the Pearson correlation. But not much conclusive evidence is seen over here. So we'll try one more correlation method which can be more useful for us, which is Spearman correlation. Let's view that. Spearman correlation is more beneficial for us as it has produced pretty much correlation with every feature for our cardiovascular disease, which is like age. With the increment of the age, the cardiovascular disease may happen. So this is a factor. Similarly for the weight, and it is also heavily depending the systolic and diastolic blood pressure over the cardio. So they are the major factors according to the Spearman correlation for the cardiovascular diseases, and cholesterol also, similarly glucose. What I have seen is the active, so the physical activity. So as much as you do the physical activity, there are less chances for the cardiovascular diseases. So this is a good point which was noted down by using the Spearman correlation. Now, since systolic blood pressure, diastolic blood pressure, and the cholesterol were the major features, we have to analyze them also. So let's analyze them. So we have systolic, diastolic, and cholesterol. So let's see that what are the factors which impact on the systolic, diastolic, and cholesterol. So we can see that the age and the weight. So if you have more weight, so there are chances of high systolic blood pressure. Similarly for the low systolic blood pressure, and similarly for cholesterol. So the weight is the major factor over here, as we can see that weight and the age. So age is not in our hands, but weight is definitely in our hands. So we can reduce our weight, we can do some exercises which can reduce the chances of having cardiovascular diseases. So I can conclude with that. Similarly, if we see BMI with cardio, it has a good weight over our analysis. So BMI is also having good evidence that we should be maintaining our weight. So this was my analysis project on US cardiovascular data. The code will be uploaded and will be attached. Thank you.